Okay, we are in section 4.5, optimization 2, and I'm going to do problem number 19 on page 324. Strength of a beam. A wooden beam has a rectangular cross-section of height h inches and width w inches. The strength S of the beam is directly proportional to its width and the square of its height. What are the dimensions of the cross-section of the strongest beam that can be cut from a round log of diameter 24 inches? So, okay, we have this beam. It's a rectangular beam. So we have a triangle here with the 24 as the hypotenuse, h is one side, and w is the other. Now, the problem says that, and the first thing you do with these problems is ask yourself, what is it that they want to minimize and what is it that they want to maximize? And in this problem, it says, what are the dimensions of the cross-section of the strongest beam? They want to maximize the strength of the beam. So let's put that down. Maximize the strength of the beam. Always establish that first. Find out what is it that they want you to maximize. What is it they want you to minimize? Because there's where you start to build your function, a relationship. Now, I don't know much about beams of wood, but it does tell us what a relationship is there to start with. We can look at a beginning working equation of some kind. It says the strength S of the beam. So the strength S is directly proportional to the width and the square of the height. Is directly, so there's a constant of proportionality, directly proportional to the width and the square of the height. So here's a working equation to start with. As in the last example, again, we have a working equation. We have too many input variables there. We need to get this strength as a function of one variable. So we have to rewrite either the h or the w. Again, we need more information to relate those and make a substitution. Now looking at the picture there, I do have a relationship between h and w. There's a triangle there with a hypotenuse of 24 inches. So I know that h squared plus w squared is equal to 24 squared. And 24 squared is 576. Now which would be better? To solve for h in terms of w or w in terms of h? Actually, in that formula, or that equation, there's an h squared. So if I solve for h in terms of w, or actually h squared in terms of w, then I can get rid of that h squared. And I will have the strength of the beam with respect to just one variable, w. And that's what I need. Now notice the k here is a constant. Now let's just see what happens. This function is with respect to w. I'm going to multiply that w into the parentheses there. 576 w minus w cubed. Now, to maximize the strength, we'll see if there's any critical points. So 576 minus 3w squared. I'm going to set that equal to 0. I might have been a little bit worried about what was going to happen to that k up to this point, but now I can just divide it out. It's a constant. So 576 minus 3w squared. And therefore 3w squared is equal to 576. W squared is 192. And W is 13.86. Now, I'm going to take the second derivative of the function, and that will be k times a negative 6w. And if I put in 13.86 there, I'm going to get a negative. So that shows me that I have found a maximum value at 13.86. So what are the dimensions of the beam? W is equal to 13.86. How am I going to get H? Well, I know that from above there, H squared is equal to 576 minus W squared. And I'll just substitute in the 13.86. And H then will be the square root of 383.9, which is 19.59. So the dimensions are 13.86 inches to 19.59 inches.